this is Lori and welcome to my project on controlling a servo with a potentiometer. We'll be using a Raspberry Pi and Python in this project. So with this potentiometer, as we turn the knob on the potentiometer, we will move the horn or arm of the servo using that potentiometer knob. So as we dial it, we can go from 0 degrees to 180 degrees using the potentiometer. So that's the goal of this project. Let's take a look at the circuit. So here's the Raspberry Pi connected to an extension board, and that brings the GPIO pins onto the breadboard for the project. Next is an analog to digital converter that I use. It's ADS 7830. And then here's the potentiometer connected into the analog to digital converter, so we can change the analog signal into a digital one for the control. And then here's our servo. It has three leads, power, ground, and then one for control, so we'll connect that up to one of our GPIO pins on the Raspberry Pi. So this is a relatively simple project, and you see a lot of folks doing this on YouTube and internet, describing how to do this. And so originally I had the servo powered from the Raspberry Pi, and as I was doing the coding, I noticed that the arm would jiggle or jitter, and it kind of was very frustrating to me why it was doing that. And so I started doing some research to see, could I remove that jitter from the arm? And so one of the first ways I tried to fix that was to power the servo separately from the Raspberry Pi. So that's why I added this power board over here, so that I could power the servo separately. And so with this board, I'm able to put 5 volts on this side of the breadboard and 3.3 volts on this side of the breadboard. So it allowed me to power these with 3.3, but also power the servo with 5 volts. Now, I will say I tried that, and I found that that didn't really solve the jittering problem. So we'll have to stay tuned to see how I finally got the jitter to go away. This is a picture of my actual experimental setup. So I just wanted to explain a little bit about how it's working. The servo is actually down here, and you can see that I put a little protractor type scale on top of the servo, added a little piece of wire so that we have a nice pointer for the arm of the servo, so we can see what angles. So I put this together so that I could see how closely I was able to use the potentiometer to dial in particular angles that I wanted. So that's why I put it here. And then as I looked at the protractor scale, I also noticed that where you start at what you call 0 depends on which way you want to start. So you can see I highlighted both scales on this protractor. One is blue and one is yellow, and I decided to go ahead and program it so that you could choose which scale you wanted to use. So that's the reason why I want to just point that out. You'll see in my code that I have the yellow scale and the blue scale. It just depends on where you want to say is 0 and where you want to say is 180 degrees. So now let's talk a little bit about the servo itself. This is the very basic servo that most people start when they're learning electronics like me. And they run a couple of dollars, so not very expensive items. And here's a picture of what's inside the servo. And when you look at that, you kind of go, wow, that's a lot for a couple of dollars. You got a motor in here, you got a potentiometer in here, a little board to control it, a gear system to drive this servo horn. So just kind of nice to see what's inside this little piece of equipment. Now, to control the servo, it expects to have a pulse sent to it every 20 milliseconds, and the length or width of that pulse is how it determines how much to move the arm. So what duty cycle we send to it tells it where and how far to move the arm for us. So one of the things we'll need in the coding is to understand what frequency we're going to want to set up our pulse width modulation control at. And just need to remember that frequency equals 1 over the period. So the period's 20 milliseconds, so that's how we get the 50 hertz when we set up pulse width modulation for a control. And lastly, I found this diagram kind of helpful too. You can see that many of these servos tend to be running from a duty cycle of about 2.5 to 12.5%. You need to experiment with the servo that you have to find its full range so that you can get the 0 to 180 degrees. It turned out for me on my servo it went from about 2 to 12%, and that worked to move the arm 180 degrees. So this slide just shows a blown up picture of the scales I'm using, the yellow and blue, and then I just also wanted to, as I have my servo oriented, you can see where the duty cycles lay in terms of pointing the arm. So when the duty cycle was 2%, it would push the arm over to this side. Around 7, I got a 90-degree angle, and then on this side it took a duty cycle of 12% to get it over here. So that's how I had it oriented. And then for the potentiometer, I set it up so that on the left side the potentiometer would give a value of 0, and when it went all the way to the right side it would give a value of 255. And I decided to make it so that whichever scale I chose to use up here, it always would give the 0 degrees on the left side and the 180 on the right side. So that meant I had to have 2 equations to determine how to move the arm. And next we'll talk about that. So this is the math that I used to figure out those equations. So I'll just show one for an example and flash up the one for blue so you can see how I did it. So with that in mind, you can see that if I want to have the 0 potentiometer value, then I wanted to, for the yellow cycle, I want it to be over here, so my duty cycle would be 2%. So that's how I got that point. And then the other side, 180 degrees, I wanted to read a 255 on the potentiometer, and it needs to be over here at 12%. So I used that to get the equation of the line, and you can go through the simple algebra to find that. And then that gives you the equation to tell you how to use the potentiometer value to determine what duty cycle you need. And then under here you can see I also wanted to print out the actual angle I was shooting for, because I wanted to see, you know, how accurate could I get with that potentiometer. Could I really dial in a specific angle? And so I also printed the angle I was shooting for to the screen as well. So I used the same kind of logic to determine what that equation should be as well. And then here you can see that I did the same kinds of calculations for the blue scale as well. So a quick review of the code I used initially to do this project. So I used the RPI GPIO library to do the control of the GPIO pins. Just point out that the SM bus library is needed for the analog to digital converter that I'm using. So we'll set up the servo and start the pulse width modulation object at 50 Hertz. Some code for me to read my ADC. And then here's the start of the program where I ask the user to choose which scale they want, the yellow or the blue. And then here is where I determine the controlling equation, the slope and intercept I need, depending on whether I have the yellow or the blue scale being used. And this is actually pretty simple. The while true loop is just really 3 lines. I just have some code here to do a printout based on the blue or yellow scale, and here's where I included the calculation of the angle. So we just read from the potentiometer, we change the duty cycle using the appropriate slope and intercept, and that's it. It's very simple. And then we'll exit the program using keyboard interrupt and clean everything up. So here's the setup. So we'll go ahead and kick off the program. And you can see we're being asked to say which scale we want, so we'll type blue. And there's the printout. I'll come down here and kind of zoom in on the control and the scale. So you can see it jittering already. It's here at the 0 for the blue scale. And we'll go ahead and turn the potentiometer smoothly. And you can see it jumping as we do that, but it does work. And we can go back. So that's the blue scale. I'll go ahead and end the program and restart it. And this time I'll type in the yellow scale. And you can see it switched to put the 0 on the other side. And now again we'll smoothly turn. And there we go. And you can really hear it when it does the jitter. Yeah. So let's see if we can fix that. So as you can see from the demo, we have a good amount of jitter on that servo arm. Powering it separately from the Raspberry Pi did not solve that jitter problem. So I did some more research and I uncovered that the gpiozero library has some functionality that might help. And that is using hardware generated pulses to control the servo rather than software generated pulses using the RPi GPIO library. So with that, it's a little more complicated. The first thing you need to do is start the Pi GPIO server running in your terminal window. So you'll have to go to a terminal and type in this code to get that started. And then you'll need to use a different pin factory that'll allow this hardware generated pulse. And so that's the code that you use to do that. The My Factory can be any name you wish. I just called it My Factory. And then to use the servo using the gpiozero library, we need to import the servo and then set it up. So you can see here, this is the code to set it up. I have it on pin 26. And then also you need to give the servo what is the range of duty cycle that you're using. And so here you can see 0.05 milliseconds over 1,000, and the max will be 2.5 milliseconds, and then use this pin factory that I've set up. Then to control where the servo is going to put the arm, you use this code, and for example here 0 is the middle of the range for how you use this particular function property, I should say, and it needs to be a value between -1 and 1 to move the servo. So instead of the duty cycle, you now have this new range, and so that means I need to recalculate those controlling equations that I was using, those lines. So I had to redo those calculations, and you can see that in the code. So just a quick review of using the gpiozero library in the code now. I'll go rather quickly. You can see that no longer importing that library, but importing the gpiozero library to use the servo. And then we're also importing the things we need for the new pin factory to use the hardware control. And here's all the things I just discussed, some code for my analog to digital converter. And then you can see that it looks pretty similar, except for I've had to change the slopes and intercepts for the two scales, and also changed how I'm moving the arm of the servo. But everything else stays pretty similar, except for the angle equations. They have to be changed as well. So that's all that's different, and so let's see how it works. Let's see if we get rid of the jitter. So now we'll try the gpiozero library, and I'm going to kick off the program. And you can see it goes to 90 degrees, and I'm going to use the blue scale, so I'll just type in blue on the screen. And you can watch it go to the 0 spot for the blue. And then we'll come in here and see how smooth it is. There you go, you can see hardly any jitter at all. And back again. I'm just going to pause for a few minutes to see if we can see any jitter. Oh, I think that hardware pulse was the ticket. So that's my project, and I want to thank you for watching.